Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast again, back with another article review. In this episode, I want to talk about a really interesting paper on interpersonal coordination or joint action, which is something I haven't really talked a lot about on the podcast. So, what we're talking about here is a task where two people are working together to form a goal, right? Think about, and here's the paper. It's a paper in Frontiers by one of my personal favorite researcher and one I consider a mentor, Reinhard Bootsma and colleagues, freezing and freeing of degrees of freedom in joint action learning. So back to, so interpersonal coordination or joint action. Think about two people carrying a box or a piano, right? You're working together to achieve a goal, move a box, lift it up there, right? And you're collaborating. Your movements are going to be interdependent. If one person drops loses control of their end, you're going to change how you're holding it, right? So overall, we're talking about an interdependent system, right? With degrees of freedom, where the degrees of freedom in this case are distributed across two people instead of in just one person, like a lot of what we've talked about on the podcast. Right. And this is one of the main points of ecological dynamics, and we take from dynamical systems theory, is a system is a system is a system. Rather, we're talking about the system of an individual and an environment. We have system level properties, or we're talking about the system of two individuals, where we have degrees of freedom that are across the two individuals. What we're going to expect is coordination across this in the whole system, not within each individual, right? Just within each, which is more traditional view, right? So what they want to do is look at how this joint coordination develops. And this is, I should mention, as I said, I haven't talked about this too much in the podcast, but interpersonal coordination and using a lot of different tasks is a very, very well-studied paradigm in ecological psychology. You find a lot of very interesting phenomena, right? When you have two people in a rocking chair, they start rocking in synchrony, even if they're not asked to, because the visual information, auditory information, there's a variety of different things. It's not, I'll admit, it's not the most realistic applied sporting task, but, as a task you'll see in this study, I think it does have some interesting implications that for how we coordinate degrees of freedom and things like that. I think it's a controlled task, and this group does a lot of real tasks like driving in sports as well. I think sometimes we have to take a step back and do a more controlled task, even though sometimes I critique these kind of things. So they're going to look at the learning of a joint task in which two agents are requiring collective control in a task environment, right? They're going to make a joint action. They use a joint action task I'm going to show you in a second, which involves rolling a ball across a beam. And what they're proposing is based on, I think it's Riley first proposed the interpersonal synergies theory. The idea that across the system, we're going to develop synergies, right? Remember what a synergy is. A synergy is when two degrees of freedom work together, right? So my shoulder is rotating a little bit slower, so my wrist rotates faster, right? That's an individual synergy. But of course, and we could have a synergy across individuals, right? So imagine, so in this task, there's basically a ball rolling on a beam, and you need to roll it from one end of the beam to the other, back and forth. There's target line. You can imagine if I had to do this myself, I'd have to lift the beam up to start rolling and then lower it back down to slow it down to get it going the other way. That kind of plan control with just 1 degree of freedom is going to require a lot of precision, right? If I lift it too high, it's going to get going too fast. I'm not going to be able to stop it. A much better way is a synergy, right? Whereas depending on how much I lift to start, the other person at the other end lifts theirs to slow it down, right? That's an interpersonal synergy. So that's what the authors were expecting to see in this task. So what is the task? So they had a task where it basically was a metal rod with a golf ball on it, right? And you had to roll the golf ball back and forth, and you had to hit these targets on each end and come back, right? There was both a joint action version with a person holding each end, their handles on each end, and there was also importantly a single solo version of this where one end was attached to a rod with a hinge, so it just rotated. You could rotate around the hinge, but you individual were controlling everything. Okay. And what they wanted to ask was how these 2 degrees of freedom contributed to the task as you learned. How did it depend on what you practiced on, whether you practiced the solo one first or the joint one first, and things like that. And what they hypothesized, interestingly, they hypothesized that this joint action learning would follow a very similar pattern to the classic Bernstein model, which I've talked about a lot on the podcast. You can Google Bernstein's degrees of freedom, freezing, right? So the idea was that initially you might see evidence of freezing, but here freezing across the system. So maybe initially we'd only use one individual moving at a time. They wouldn't be working together for the task. Because we're taking 1 degree of freedom out of the system, it makes it easier to control initially. So we'd see initial freezing degree of freedom and movement towards freeing, right? Because I said, as I illustrate with my example, right, a synergy is going to be much more effective when people are working together than if one person is just controlling it. And they also hypothesized that this progression from freezing to freeing, which, as I said, I've talked about on the podcast before, there's lots of evidence to show this occurs on an individual level. But what we're going to see is, well, they expected this to happen more in people that were allowed to do the solo task first and then move to the joint task. The reason being the solo task essentially has freezing in it, right? The other end of the rod is frozen. It's not adding any coordination or movement into it. Okay. So they've already experienced the freezing task. Maybe they would be quicker to free degrees of freedom once they move to the joint task. Okay. So that's the basic hypothesis. As I said, it's a very interesting extension of Bernstein's theory. The methods had 24 students. As I said, it was a metal rod with a V shape and a golf ball fit in the middle. There was 2 red marks on each end that you had to roll, touch the red mark, get it going the other way, back and forth, back and forth. You got 1 point every time the ball reverse direction within the target zone, right? Within 2-minute trials. And as I mentioned, there was both a joint action with another person on the end and a solo action with the ball attached to a static pole who had a hinge on it. Okay, so that's the basic design. There was 2 sessions on 2 different days. There was 1 to 2 days between the sessions. Importantly, people were split across 2 groups, right? So we had a group that all practiced the solo task first, then moved to the joint task, and a group that did the reverse, all did the joint task and moved to the solo. Okay, so they're kind of counterbalance, but we're going to look at how these 2 performed, right? So those are the 2 training groups. And what they analyzed, of course, various performance measures, how many points you got, how fast the ball was moving, how much you moved the beam. But interestingly, what they're really interested in was interpersonal coordination. For this, they developed 3 ratios, what they called the supplementary ratio. That is how much percent of a trial were the 2 people moving the beam in the same direction, right? Both lifting it up. How much of the percentage of the time were they complementary ratio, which were they moving the opposite directions, which you might expect when you see a synergy, you expect more complementary motion. And then finally, what percentage of the trial was was one person moving the beam less than a certain speed, a very, very low speed, indicating they're freezing. They're not moving at all, right? So these are the 3 ratios they're going to look at across the course of training. Okay, so that's the basic design. Let's look at some results. So if we look at the results in terms of score, what you find is everybody improved over practice, okay? There was a general pattern. People performed the task better doing it jointly than solo, no matter what, whether that was first or second. They always performed better when they were doing the joint task than when they did the solo task. But by far, the best performance occurred in the condition where people were doing joint action in the participants who had got to do the solo first. So move from S to J, solo to joint. That was the best scores we see as predicted, right? That's where you can see the best coordination. We'll get to why in a second. There was a similar effect if you looked at ball speed. Ball speed was higher when you did solo first and moved to joint. Accuracy was more if you looked at the effective, how precisely within the zone they turned the ball around. It was higher as well for the SJ group, the group that did solo then joint. Okay, let's move to interpersonal coordination. So for this, remember, there's these 3 ratios. Okay, what they found was, interestingly, across training for all groups, the freezing ratio, right, and the supplementary ratio were initially fairly high. Okay, so one person not moving or both people moving in the same direction, while they decreased over practice, which is what you might expect. It's freeing degrees of freedom, starting to develop synergies, which was also seen in the complementary ratio, which increased over practice. The freezing ratio was significantly lower in the SJ group when they were performing the joint task. It was only seen on 26.7% of the trials time, whereas for the group that went from joint to solo, it was significantly higher, almost 50%. With the complementary ratio was similarly higher in the solo to joint group, 60%, and then in the group that went joint to solo, 37%. What they also did, I'm not going to go into super detail. They also analyzed freezing on an individual level, right? So looked at whether the reason there was more freezing is because there's just more individual freezing, or whether it was happening at the same time. Or what they found was essentially the freezing showed evidence of kind of a system, right? So people were freezing sequentially. One person would stop moving, the other would move. What the other person would stop, the other would move. So they were working together by freezing at certain times, right? So they weren't just freezing on an individual level. That's important. Okay, so what does all this mean, right? So what we're seeing is people learning to coordinate the system by coordinating degrees of freedom across two individuals, right? That's influenced by the training they got beforehand, right? So if we first look at the group that went from joint, so they performed the task jointly and then moved to solo, right? So they didn't get we're not mostly concerned with the joint task, but they didn't get the solo experience first. What they found was this group had much more evidence of freezing degrees of freedom. And what this type of freezing was sequential turn taking. It was seemed to be a strategy, right, of interpersonal coordination rather than an individual level. Although they eventually began to free the degrees of freedom, so doing more less freezing, overall they still had a relatively high amount of freezing even at the end of training. Okay, compare that with the group that went from solo to joint, right? From solo to joint, they had much less freezing in the joint task, about 27%, compared to the joint to solo, which was 50. They demonstrated more complementary directions where they're working together, moving in opposite directions. And they seem to be coordinating their degrees of freedom. They're developing a synergy where I lift up, you lift up, right? Or you lift down, right? They're working together as a system to coordinate, to achieve, and of course, they achieve the best performance overall, right? Which is what Bernstein predicts, right? You need to eventually move from freezing to freeing, because freeing is a more sophisticated movement solution. It allows for more adaptability and much better performance, right? In this case, as I said, the freezing degrees of freedom is going to require a lot of precision in how much you lift the bar up initially. If you lift it too high, the thing's going to get going too fast, right? You're going to have a hard time slowing it down. If you have two people working together, you're going to have much, much more control online. It doesn't matter so much. You get it exactly right the first time. Right. So I think this is a really, really interesting study showing that Bernstein's freezing and freeing degrees of freedom work across individuals as we would predict in ecological dynamics, because there's nothing special about an individual when in this. They're part of a system, right? They're part of a system of degrees of freedom. Whether they're in the same body or not is not particularly relevant here, because they're based on information, right? They're information driven from the environment, not some internal model in the person's head. And I'll end with, this is a slide that I did a presentation. There's an episode on this, and I think on my YouTube channel you can find my presentation on freezing and freeing degrees of freedom and the evidence and the research related to it. And one of the things I put up was this slide: how degrees of freedom are strongly related to task constraints in practice, right? And this is what they're showing: that practice with initial solo task changed how you coordinated on a joint level, right? So how we coordinate degrees of freedom, how we solve degrees of freedom, the movement solutions we come up depend on the task environment we create, the practice. Adding more variability to practice creates more synergies, is what I've found in previous studies. Also, they've been shown there. So again, similar finding: your experience shapes how you coordinate your movements. Not surprisingly, right? So again, I think this is a really interesting study. I encourage you to have a look. And if you're interested, as I said, there's a huge literature on joint interpersonal coordination and joint action in the ecological psychology field. So thanks for joining me. Cheers for now, and keep them coupled.